Okay, so for this equation, we're going to look at an RC circuit, and that has a resistor and a capacitor, and in this case, the inductor is missing. So look at our equation. Our R is 20 ohms, so we're going to first have that, and that's 20 ohms times Q prime, plus our capacitor, which is 0.1, so that's 1 over 0.1 times Q, and that's equal to our electromagnetic force, which this time is a generator. It's 100 times the sine of 2t. Once again, we need to put this into standard form. Fastest thing to do is take the 0.1 and take the reciprocal, so that's actually 10 times q is equal to 100 sine of 2t, and then divide everything through by 20. So we end up with Q prime plus 1/2 times Q is equal to now 5 times the sine of 2t. And our integrating factor this time around is just mu of t is e to the integral of 1/2 dt. So that's just e to the 1/2 t. Once again, we multiply it in and rewrite this as a derivative of a product. So this is e to the 1/2 t times q that we're differentiating is equal to 5 e to the 1/2 t times the sine of 2t. And we now integrate this with respect to t on both sides. And on the left-hand side, we get e to the 1/2 t times q. On the right side, that's an integral that would require parts twice. So to avoid using parts twice, we'll just use a handy-dandy formula that we have off to the right. So that's going to be the exponential, which is e to the 1/2 t divided by the sum of 1/2 squared plus 2 squared. So if we take our 0.5 and we square it, and we add that to our 2 and square it, and then take the reciprocal and convert it to a fraction, we end up with 4/17. So this is going to be writing this as a coefficient instead. It's 4/17 e to the 1/2 t, and then we're going to have the a, which is going to be the coefficient on the exponential, so that's 1/2 sine 2t minus the b, which is 5 cosine of 2t. And this is then plus a constant c. And then we can divide through by the exponential, e to the 1/2 t. And that's going to give us our q of t, which is 4/17 times 1/2 sine of 2t minus 5 cosine of 2t plus c times e to the negative 1/2 t. Again, there's no charge, so q of 0 is equal to 0. So that's equal to, evaluating this, we get negative 20 over 17 plus c, and again that makes a 0. So c is 20 over 17. So our q of t is 4/17, 1/2 of the sine of 2t minus 5 cosine of 2t plus 20 over 17 e to the negative 1/2 t. So that's our charge, and to get our current, all we have to do is take the derivative. So I of t would just be equal to q prime of t, and that's just going to be a simple application of some rules from trig and exponentials. All right, so that's how we handle an RC circuit.